Hey everyone, today we're going to learn about chemical reactions and equations. First of all, the big question. What exactly is a chemical reaction? Basically, it's a process in which a substance termed as a reactant is converted into a different, or let's say, new substance which is termed as a product. In this process, the reactant undergoes changes, mainly due to the breaking of the bonds between its constituent molecules. Such a process is shown in the form of an equation. An example of such a process is the formation of water. Here, two molecules of hydrogen react with one molecule of oxygen to form two molecules of water. Now, we're going to learn about three different types of chemical reactions, namely oxidation, reduction, and redox reactions. First up is oxidation. In oxidation, the reactant either combines with one or more oxygen atoms or loses one or more hydrogen atoms, like the formation of carbon dioxide, where carbon combines with an oxygen molecule, or when hydrochloric acid, on reaction with sodium, loses its hydrogen atom to form sodium chloride and hydrogen gas. Another definition of oxidation is a reaction where the reactant loses one or more of its valence electrons. The reaction of iron with sulfur to form FeS, that is iron sulfide, iron gets oxidized as it loses two electrons. Here's an experiment based on oxidation. In this experiment, we heat zinc in a test tube to form zinc oxide. First, we add a small amount of zinc dust to a test tube using a spatula. The zinc dust, as you can see, is grey in color. Then we fix the test tube to a test tube holder and slowly heat it in an oxidizing of the blue part of the flame. As you can see, a white powder forms on the sides of the test tube. This white powder is zinc oxide, and therefore, here, zinc undergoes oxidation to form zinc oxide. Now, we move on to reduction, exactly opposite to oxidation. In reduction, the reactant either loses one or more oxygen atoms or gains one or more hydrogen atoms. Like in the decomposition of aluminium oxide, where two molecules of aluminium oxide undergo reduction to liberate three molecules of oxygen gas, while four aluminium molecules remain as residue. Or when CuO, that is copper oxide, loses its oxygen atom to undergo reduction on reaction with hydrogen to form metallic copper and water. And again, exactly opposite to oxidation, reduction is also defined as a reaction in which the reactant gains one or more electrons. For example, when zinc reacts with hydrogen ions, the two hydrogen ions gain one electron each, thus undergoing reduction to give hydrogen gas, while zinc turns into Zn2 plus ions. Here's an experiment based on reduction. In this experiment, we heat HgO, that is mercuric oxide, to form mercury and liberate oxygen. Here we have HgO, that is mercuric oxide, which is orange in color. We take this in a test tube. Then we fix the test tube on a test tube holder, and then we heat it slowly. As you can see, Slowly, a white powder like substance is observed on the upper part of the test tube, and the mercuric oxide slowly starts to turn red. As the mastic is held in the upper part of the test tube, after a while it catches fire. This is due to the formation of oxygen, catalyzed by the heat, and the orange mercuric oxide turns dark red. Therefore, as per the second definition, if the positive charge of the reactant atom increases or its negative charge decreases, then the atom undergoes oxidation. If the positive charge decreases or its negative charge increases, it is undergoing reduction. Now we will talk about the reagents involved in oxidation and reduction. The first one is the oxidizing agent, also known as the oxidant. An oxidant is a substance, or should I say reactant, that gets reduced in a chemical reaction in order to bring about oxidation. For example, when bromine is reacted with hydrogen sulfide, it gets reduced by accepting a hydrogen atom, which causes the sulfur to get oxidized by losing hydrogen. Hence, bromine becomes HBr, that is hydrogen bromide, and H2S, that is hydrogen sulfide, becomes sulfur. The second is the reducing agent, also called the reductant. Exactly opposite to the oxidant, the reductant undergoes oxidation itself to bring about reduction in a chemical reaction. For example, in the same reaction as the one used for explanation of the oxidant, as the sulfur gets oxidized, it causes bromine to be reduced. Therefore, sulfur here is the reducing agent. Here are some questions for practice. Pause the video to solve them if you'd like to, and check your answers to the ones given here. We move on to the third category of chemical reactions, which is redox reactions. The name redox itself is a combination of reduction and oxidation. In redox reactions, reduction and oxidation take place at the same time. For example, the reaction between ferric oxide, that is Fe2O3, and carbon monoxide, that is CO, Fe2O3 gets reduced to Fe, while at the same time CO gets oxidized to CO2. In the reaction between copper oxide, that is CuO, and hydrogen gas, CuO is reduced to Cu, whereas simultaneously hydrogen gas is oxidized to H2O. Here's an experiment based on redox reactions. Here we add zinc to copper sulfate solution to form zinc sulfate and copper. Here in separate petri dishes we have zinc dust and copper sulfate powder. First we add some of the copper sulfate powder to a small amount of distilled water in a test tube. Then we mix the solution well by vigorously shaking the test tube. The solution should have a clearly visible blue color. If the solution is in clearly blue, we add some more amount of the copper sulfate powder and repeat the same steps as before. Once a clearly blue solution is obtained, we add some amount of zinc dust to it and lightly shake the test tube. Slowly, the solution becomes transparent and a black powder is seen at the bottom of the test tube. The clear solution is of zinc sulfate, that is ZnSO4, and the black powder is of copper. Here are some more practice questions. based on the reagents as well as on redox reactions. Feel free to solve them if you'd like and refer your answers to the ones given here. Finally, we talk about corrosion. Corrosion is a natural process. It causes a refined metal to turn into an oxide that is chemically stable. It causes materials to gradually break apart as they react either chemically or electrochemically with their surroundings. As an example, we talk about the process of rusting. Rust is a reddish layer that forms on the surface of metals. Chemically, it is Fe2O3.xH2O, formed due to a reaction of iron with oxygen, with water acting as a catalyst. The reaction is an electrochemical one, and the different areas on the iron surface turn into the anode and the cathode. The process is as follows. First, Fe in the anode area loses 2 electrons per atom, getting oxidized to Fe2+. Next, oxygen gains 4 electrons and combines with 4 hydrogen ions to form 2 molecules of water in the cathode region. Then, the Fe2+ ions travel from the anode area to the cathode area, where they get further oxidized to Fe3+ on reacting with water. Every 2 of these Fe3+ ions react with 4 water molecules to form Fe2O3.H2O, which is rust, and release 6 hydrogen ions. Here is a visualization of the process of rusting. An example of corrosion is the corrosion of the Statue of Liberty. The outer layer of copper of the statue, on coming in contact with the inner framework that is made of iron, is causing the statue to corrode. Hope you understood these lessons. Thank you so much for watching the video.